Hi, this is a video on conic sections, circles and parabolas. Conic section is taking the three-dimensional figure of a cone and slicing it. And then when you slice it, if you look at the edge, you will see the different shapes that we call conic sections. So to get a circle, for instance, if I sliced the cone this way, and then I looked at the edge that was created with that slice, I would have a circle. So that's why they're called conic sections. And you've seen these before, possibly. Here is a circle, and what we would want to do with a circle is we would want to be given, say, 2 points for the circle. I'm going to take this point as the center, and I'm going to take this as a point on the circle. And then if we look at what that just looks like briefly, I would have, say, -1, -4, so I say I'd have a center down there, and then I'd have a 0.57 up here, and then that would be, so that would be the circle. And I'd want I'd want to find the equation for that circle. So that's what we're doing here, trying to find the equation of a circle. And we simply plug into the equation. X minus h is the x-coordinate of the vertex. So you should make a note of that, if that isn't already obvious. H is the h-coordinate of the vertex, and y is or k is the y-coordinate of the vertex. So since I'm given my center here at -1, I can plug in a -1 for h. I can plug in a -4 for k, and then of course I need r squared, which I could find easily enough by using the distance formula. So hopefully you recall the distance formula from a previous class, and it's the square root of the difference between the x's squared and the y squared. So we use that distance formula to find this radius, and we get rad 157. And then I can plug that in, of course, up here into the equation, and my equation for my circle will be complete. I'll just clean it up a little bit here. X plus 1 squared plus y plus 4 squared. And then that this rad 157, which is the radius, that'll be squared. So we'll just have 157. So that's simple enough, finding the equation of a circle. So here's some finding the equation of a circle given some different information. Here we're not given the center. So if we were given these points, what we're trying to find is -3, 2, and 7, -2. So these are on the circle. So the circle is out here. I want to do the equation of that circle. So I'm going to have to find the center, wherever the center is. So we would want to find the midpoint, which the midpoint would be the center of the circle. And again, from geometry, that would be the difference between these two divided by 2. I should say sum, actually, okay. And then the sum of these two, 2 plus -2 divided by 2. And that will give us the midpoint, which would be at 2, 0, if I'm calculating correctly. So that would be the center, and then from there, it's simply a matter of plugging into the formula, x minus 2 squared plus y minus 0 squared is equal to r squared, and we could find r squared like we did on the previous problem. So that's enough, simple enough for circle. Now parabolas are something that we've seen quite a bit of before. We've worked with quite a bit. And what we're familiar with the parabolas is this equation and this equation. And we've worked with these quite a bit. Now, when we talk about parabolas in the context of a conic section, we're going to be looking at this equation and this equation. So just take a moment and particularly look at this equation here and see how that compares to what we've done with parabolas, or what you've done a lot more with parabolas, which is this equation. So you can see with a little bit of rearrangement, they're really similar, these two equations. In fact, and something that's very important to come out of here is to observe that in this equation, if I compare the a and the 4p, a is equal to 1 over 4p. So that's important enough that really the way that I prefer to write the equation, although a textbook will write the equation for a parabola as I have shown here, all right? So this is what a textbook is going to show in the context of talking about a parabola as a conic section. But what I just prefer to revert to what we've already done. We've said y minus k is equal to a times x minus h squared. Similarly, over here I would say x minus h is equal to 1 over 4p times y minus k. So that's just a little rearrangement of the formula, and you can take a moment and make sure that you follow that arrangement. Now, with that arrangement, we can see this key relationship is this 1 over 4p. And so we're just plugging in 1 over 4p into the equation for A. And I'll talk about what p stands for in a moment. So that's what I'm going to do with these two equations. I'm just going to go in and I'm going to replace A when I'm talking about a conic section and replace it with 1 over 4p. Okay, now what does the p represent? Well, first of all, with these equations, this one, which is like the y equals x squared, right? That's like our original y equals x squared type of parabola is a parabola that's either opening up or it's opening down. And then this one where I've got x and then the y is squared, that's going to be a parabola that's either opening to the side, to the right, or opening to the left. All right. Now, if I take any one, let's just take one of these, and let's briefly talk about what is a parabola. So, like if you think about what is a circle, that's a set of points. All of these points are equidistant from some point, which is the center, right? So, what is a parabola? I'll just do that in the same place. A parabola is a set of all points such that the points are equidistant from some point called the focus. So this point is called the focus, and some line called the directrix. So this is the directrix here. And all of the points that are equidistant from this line and this focus are what create the parabola. So you should think about that and make sure that you understand what I'm saying there, really just for interest's sake, that any point, so if I go to this point here, and then I see how far is that point from the directrix, these two distances are equal. If I take another point on this, and the distance from that point to the focus is the same as the distance from that point to the directrix, and that distance is equal. So that's what a parabola is. And this p value right here, that's the distance that we're talking about, really the minimum distance, or the distance right here. So this distance right in here, that's p. So it's the distance from the vertex. P is the distance from the vertex to the focus, which is the same as the distance from the vertex to the directrix. So if you need to go back and listen to that, what I just said there again, make a note on it. That's the key understanding with looking at a parabola as a conic section. So now let's find the equation of a vertex, of a parabola. So we're given the vertex and the focus. So the vertex is out here, say at 5, 2, and the focus is in here at 3, 2. So those would be 0.32 for the focus and 0.52 for the vertex. Now, if the vertex is here and the focus is here, the parabola has to be opening like this. And that's key. So there are two things that we've got here. We've got the vertex opening to the left, and we've got the vertex being a side-to-side vertex. We got the parabola opening to the left, and we've got the parabola opening it's side-to-side, right? So let's look at back here. What did I say? I said this is the equation down here. This is the equation that we use when we're dealing with a parabola that is opening to the left or to the right. So I'm just going to pull that equation forward. All right, so here it is, the equation that we need, and we're just going to fill in here, fill in the spots. So h is this h here is the x coordinate of the vertex. So it's going to be x minus 5. This p here, remember p is the distance. This p here is the distance from the focus to the vertex. So from the vertex to the focus here, and we can see that that's 2 units. So that's 2. And then this y minus k is going to use the y coordinate of the vertex. And then very important here, since this is opening to the left, we're going to make this negative. All right, so there it is. There's the equation of the parabola, and then we can simplify that a little bit. And we've got it. Easy enough. All right, well, maybe we'll look at one more example. All right, so this is a little bit interesting. I've got 2 equations here, and we should be able to look at these and tell what shape would this equation be. And the giveaway here is looking at the x squareds and the y squareds, or the lack thereof. So here I've got x squared, y squared. Later on we're going to see that it's a key that it's a sum, and it's a key that they have the same coefficient. And based on all of that, I can tell just by looking at this equation that this equation is going to graph as a circle. Now this other equation here is I've got x squared, and you see I don't have y squared. I've got y to the first. So that is what's telling me that it is a parabola. If we go back to our first ever parabola, it was y equals x squared, right? One of them was squared and one of them wasn't. So that's the case here, and I know I have a parabola. Now what might happen here is I might be asked something about the circle, like where's the center of the circle based on this equation. So I'm not going to do that one, but what I do with the parabola is very similar. So you should be able to do that if you can follow what I'm doing with the parabola. Because what I'm going to do with the parabola is I'm going to say, where's the vertex? Okay? So I'm going to take the x's here, x squared plus 4x, and I'm going to complete the square. And I'm allowed to add that, like that, and complete the square, as long as I add it to the other side. All right, so I'm going to have x plus 2 squared plus, I'm actually going to rearrange it and say equals. And I'm catching an error here. When I added this, when I added that 4, I only added 2 over here. So I got to add 4 over there. So there, that's fixed. And then one more operation here, and I will have the vertex. I just got to factor out the -6 there, and then the vertex is, it's the opposite, right? So it's going to be -2, +1 is the vertex. All right, now for a circle, I would complete the square for both the x's and the y values, and then that would give me the center of the circle. So it's just another advanced problem that we can do with conic sections.